Hello and good morning, everyone. Let me share my screen. So we have started with our third unit last time, that is working with public clouds. So the basic structure, what is public cloud, why public cloud is required, and when to opt for public cloud. These points we have seen in our last lecture. Just we'll go through the same once again. So what is public cloud? It's a definition like public cloud is a cloud deployment model where computing resources are owned and operated by a provider and shared across multiple tenants via the internet. So the best example for this we have seen like the Amazon Elastic Compute Cloud, that is EC2, Microsoft Azure, IBM's Blue Cloud, Sun Cloud, and Google Cloud. These are the examples of public cloud here. So if we see the properties, so public cloud, it provides the shared platform which is accessible to the general public through an internet connection. Also, it is operated on pay-per-use kind of a model, which is administrated by third party. And the same storage is being used by multiple users at the same time. Also, again, it is owned, managed, and operated by business, universities, government organizations, or a combination of them. So we can see our college example also, that where we are using or we have owned the Google platform here, through which we are using the facility of our mail service, using the drive, the storage locations, almost about I think 2 GB to 5 GB something data storage to each and every user of the college is being provided. So it's a like this particular public cloud service is being provided to us via Google. It is owned, managed, and operated by our organization here.
किती किलो आहे? किती किलो आहे? 90 रुपये झाले, 150 त्याला झाले.
Please mute your mic.
100 250
Radhika Sapure, please mute your mic. Okay, and then why to go for the public cloud? So some of the reasons like lower equipment purchase cost is there, and lower equipment maintenance cost is there. That benefits we have seen. Here also we can see that Google, the core team of Google is providing us the facility of security and all others, isn't it? So we don't have to bother about the security related to our data on our Google Drive. Just we have to do is what? we have to save our password from others or the hackers, isn't it? So no need to purchase any new equipments over here for maintaining the cloud. Just you need internet connection through which you can go for using the public clouds. Also, lower equipment maintenance cost. Whatever the equipments are there with you, no need to go for the maintenance of them. Okay. Then we have seen the how the public cloud works and the difference point, that is public cloud, private cloud, and hybrid cloud. The difference between these three, that part also we have seen. Right. Then when to opt for public cloud? So some of the reasons like cost effectiveness, quick and easy setup, optimization of stuffing budgets, no maintenance, no long-term contracts, economics of sale, agility, global in minutes, high flexibility without redundancy, and maximum uptime and zero risk of failure. These are the reasons to go for public cloud that we have seen last time in detail. Then again, 10 considerations to choose between public or private clouds like security, data ownership, maintenance and retention, then performance and availability, support and self-service, enhancement and update for policies, integrations, usability, contractual flexibility, like subscriptions versus license fee, then infrastructure scalability, and the reference in customer recommendations. These are some of the reasons why to go for public cloud. Those all reasons in detail we have seen in our last lecture. Then we saw the things like public cloud service model, in which we have studied the already this software as a service, infrastructure as a service, and platform as a service. This part we have gone through in our last unit, that is the first unit. Just once more the light is been thrown here on these bits in this unit. So here we need to see the top 10 cloud service providers here, or the cloud service providers. चालू नको जरा. So there are many resources present on the internet for the same. काय करते तू? Sorry for the interrupt. One good video related to the same I found.
Daily life. SaaS is a part of almost everyone's daily life. Software as a Service, or SaaS, is one of the three main categories of cloud computing and the most common with consumer-level products alongside Infrastructure as a Service and Platform as a Service. Simply put, the as a service translates to over the internet. So, SaaS is a third-party application available over the internet with no physical connection to any one device. Your email client is likely SaaS. Google Docs and Microsoft Office 365 are SaaS, providing productivity apps over the internet. For businesses, there is SaaS for sales management, customer relationship management, financial management, human resource management, billing, collaboration, really anything. SaaS applications are used by a range of IT professionals and business users, as well as C-level executives. Leading SaaS providers include Salesforce, Oracle, SAP, Intuit, and Microsoft. Because SaaS eliminates the expense of hardware, maintenance, licensing, and installation, it can be cost-effective. SaaS offerings generally operate on a pay-as-you-go model, offering businesses flexibility. SaaS also offers high scalability for any range of projects and needs, automatic updates, which reduces the burden on IT, and accessibility and persistence, since users can access SaaS content from any internet-connected device and location. But a notable disadvantage is the fact that organizations must rely on outside vendors for the software and have little control. For instance, providers might experience service disruptions, impose unwanted service changes, or fall victim to a security breach. What was the first SaaS your company embraced? Salesforce? Office 365? Let us know in the comments below, and please hit that like button.
some discussion SaaS is being given. Then next is, as per the syllabus, we are having AWS. It's a basic compute, storage, networking, and IAM services. So for that, I will go for this.
Hello everyone, let me introduce myself as Sam, a multi-platform cloud architect and trainer, and I'm so glad and I'm equally excited to talk and walk you through this session about what AWS is and talk to you about some services and offerings and about how companies get benefited by migrating their applications and infra into AWS. So what's AWS? Let's talk about that. Now, before that, let's talk about how life was without any cloud provider, and in this case, how life was without AWS. So let's walk back and picture how things were back in 2000, which is not so long ago, but a lot of changes for better had happened since that time. Now, back in 2000, a request for a new server is not an happy thing at all, because a lot of money, a lot of validations, a lot of planning are involved in getting a server online or up and running. And even after we've finally got the server, it's not all said and done. There are a lot of optimization that needs to be done on that server to make it worth it and get a good return on investment from that server. And even after we have optimized for a good return on investment, the work is still not done. There will often be a frequent increase and decrease in the capacity, and even news about our website getting popular and getting more hits, it's still an bittersweet experience, because now I need to add more servers to the environment, which means that it's going to cost me even more. But thanks to the present day cloud technology, if the same situation were to happen today, my new server, it's almost ready, and it's ready instantaneously. And with the swift tools and technologies that Amazon is providing in provisioning my server instantaneously and adding any type of workload on top of it and making my storage and server secure, creating a durable storage where data that I store in the cloud never gets lost, with all that features, Amazon has got our back. So let's talk about what is AWS. There are a lot of definitions for it, but I'm going to put together a simple and a precise definition as much as possible. Now, let me iron that out. Cloud still runs on an hardware, all right? And there are certain features in that infrastructure, in that cloud infrastructure, that makes cloud, or that makes AWS a cloud provider. Now, we get all the services, all the technologies, all the features, and all the benefits that we get in our local data center, like, security and compute capacity and databases. And in fact, we get even more cool features like content caching in various global locations around the planet. But again, out of all the features, the best part is that we get everything on a pay-as-we-go model. The less I use, the less I pay, and the more I use, the less I pay per unit. Very attractive, isn't it? Right? And that's not all. The applications that we provision in AWS are very reliable because they run on a reliable infrastructure, and it's very scalable because it runs on an on-demand infrastructure, and it's very flexible because of the designs and because of the design options available for me in the cloud. Let's talk about how all this happened. AWS was launched in 2002 after the Amazon, we know as the online retail store, wanted to sell their remaining or unused infrastructure as a service or as an offering for customers to buy and use it from them, sell infrastructure as a service. The idea sort of clicked, and AWS launched their first product in 2006. That's like 4 years after the idea launch. And in 2012, they held a big sized customer event to gather inputs and concerns from customers, and they were very dedicated in making those requests happen. And that habit is still being followed. It's still being followed as reinvent by AWS. And at 2015, Amazon announced its revenue to be 4.6 billion, and in 2015 through 2016, AWS launched products and services that help migrate customer services into AWS. Well, there were products even before, but this is when a lot of focus was given on developing migrating services. And in the same year, that's in 2016, Amazon's revenue was 10 billion. And not the least, as we speak, Amazon has more than 100 products and services available for customers and get benefited from. Alright, let's talk about the services that are available in Amazon. Let's start with this product called S3. Now, S3 is a great tool for internet backup, and it's the cheapest storage option in the object storage category. And not only that, the data that we put in S3 is retrievable from the internet. S3 is really cool. And we have other products like migration and data collection and data transfer products. And here we can not only collect data seamlessly, but also in a real-time way monitor the data or analyze the data that's being received. That there are cool products like AWS data transfers available that helps achieve that. And then we have products like EC2, Elastic Compute Cloud. That's an resizable computer where we can anytime alter the size of the computer based on the need or based on the forecast. Then we have simple notification services, systems and tools available in Amazon to update us with notifications through email or through SMS. Now anything can be sent through email or through SMS if we use that service. It could be alarms or it could be service notifications if you want, stuff like that. And then we have some security tools like KMS, Key Management System, which uses AES 256-bit encryption to encrypt our data at rest. Then we have Lambda, a service for which we pay only for the time in seconds it takes to execute our code, and we're not paying for the infrastructure here. It's just the seconds the program is going to take to execute the code. If it's a short program, we'll be paying in milliseconds. If it's a bit bigger program, we'll be probably paying in 60 seconds or 120 seconds. But that's a lot cheap, lot simple, and lots cost effective as against paying for service on an hourly basis, which a lot of other services are. Well, that's cheap, but using Lambda is a lot cheaper than that. And then we have services like Route 53, a DNS service in the cloud. And now I do not have to maintain an DNS account somewhere else and my cloud environment with AWS. I can get both in the same place. Alright, let me talk to you about how AWS makes life easier, or how companies got benefited by using AWS as their IT provider for their applications or for the infrastructure. Now, Unilever is a company, and they had a problem, right? And they had a problem and they picked AWS as a solution to their problem, right? Now, this company was sort of spread across 190 countries, and they were relying on a lot of digital marketing for promoting their products. And their existing environment, their legacy local environment, proved not to support their changing IT demands, and they could not standardize their old environment. Now, they chose to move part of their applications to AWS because they were not getting what they wanted in their local environment. And since then, rollouts were easy, provisioning new applications became easy, and even provisioning infrastructure became easy, and they were able to do all that in push button scaling. And needless to talk about backups that are safe and backups that can be securely accessed from the cloud as needed. Now, that company is growing along with AWS because of their swift speed in rolling out deployments and being able to access secure backups from various places and generate reports, and in fact useful reports out of it that helps their business. Now, on the same lines, let me also talk to you about Kellogg's and how they got benefited by using Amazon. Now, Kellogg's had a different problem. It's one of its kind. Now, their business model was very dependent on an infra that will help to analyze data really fast, right? Because they were running promotions based on the analyzed data that they get. So they being able to respond to the analyzed data as soon as possible was critical or vital in their environment. And luckily, SAP running on HANA environment is what they needed, and they picked that service in the cloud, and that sort of solved the problem. Now, the company does not have to deal with maintaining their legacy infra and maintaining their heavy compute capacity and maintaining their database locally. All that is now moved to the cloud, or they are using cloud as their IT service provider, and now they have a greater and powerful IT environment that very much complements their business. I believe you enjoyed watching this video. Stay tuned. I'll meet you in another video. Thank you.
Visitors. On Black Friday, another Meet Rob. He runs an online shopping portal. The portal started with a modest number of users, but has recently been seeing a surge in the number of visitors. On Black Friday and other holidays, the portal saw so many visitors that the servers were unable to handle the traffic and crashed. Is there a way to improve performance without having to invest in a new server? Wondered Rob. A way to upscale or downscale capacity depending on the number of users visiting the website at any given point? Well, there is. Amazon Web Services, one of the leaders in the cloud computing market. Before we see how AWS can solve Rob's problem, let's have a look at how AWS reached the position it is at now. AWS was first introduced in 2002 as a means to provide tools and services to developers to incorporate features of Amazon.com to their website. In 2006, its first cloud services offering was introduced. In 2016, AWS surpassed its $10 billion revenue target. And now, AWS offers more than 100 cloud services that span a wide range of domains. Thanks to this, the AWS Cloud Service Platform is now used by more than 45% of the global market. Now, let's talk about what is AWS. AWS, or Amazon Web Service, is a secure cloud computing platform that provides computing power, database, networking, content storage, and much more. The platform also works with a pay-as-you-go pricing model, which means you only pay for how much of the services offered by AWS you use. Some of the other advantages of AWS are security. AWS provides a secure and durable platform that offers end-to-end privacy and security. Experience. You can benefit from the infrastructure management practices born from Amazon's years of experience. Flexible. It allows users to select the OS, language, database, and other services. Easy to use. Users can host applications quickly and securely. Scalable. Depending on user requirements, applications can be scaled up or down. AWS provides a wide range of services across various domains. What if Rob wanted to create an application for his online portal? AWS provides compute services that can support the app development process from start to finish. From developing, deploying, running, to scaling the application, up or down based on the requirements. The popular services include EC2, AWS Lambda, Amazon Lightsail, and Elastic Beanstalk. For storing website data, Rob could use AWS storage services that would enable him to store, access, govern, and analyze data to ensure that costs are reduced, agility is improved, and innovation accelerated.
From Simply Learn, and let me help you understand about AWS EC2, a compute service in the cloud, through this video. Somewhere far in the country, a scientist has a lab far in the woods, and at one day he stumbled on a calculation that he had trouble solving, and he was very certain that his computer can handle it. And he asked his computer to do the math or the calculation for him, and the computer thought about it for a while, then took a couple of hours in trying to process the data, and eventually at one point it gave up and died due to low memory. And this old scientist is now clueless about how he was going to finish the task and complete his invention and let the whole world know about it. And that's when he was introduced to this new friend AWS, as you see on the screen. AWS was very handy in replacing his old machines, and it was able to give him the service that he wanted at that moment. AWS has been around for a while helping people with their computer needs, and now this new scientist friend in need is welcomed by the new and trendy IT technology AWS, and sure enough, his new AWS friend welcomed and walked him through the new way of computing. And this new happy-faced AWS friend talked to this scientist about AWS EC2 in specific, and walked him through about all the new innovations in IT and in cloud that he had been missing all these days. So his new friend AWS started the conversation about explaining how there is no need for any hardware units, no managing hardware or provisioning in AWS. And secondly, it explained increasing and decreasing the capacity as per the demand is just a click away. And the best part here is that there is no upfront commitment and we only pay for what we have used, just like we pay electricity and water bills. And all this comes with complete control from our side. In other words, the whole key for this infrastructure is with us. And as if this was not enough, all this comes with enterprise grade security that's beyond imagination in on-premises. And if this still does not excite you, then this definitely would. You can work from anywhere in the world. Now this really made the scientist to get excited, especially when he thought about working from home. Working from home, there is nothing like it, isn't it? Now this person, this scientist, is not tied up to a particular environment. He can work from home, work on the fly, work from anywhere. Still, the data and everything else in his IT environment is secure and safe. Now let's move to the next level of discussion. Let's talk about what is EC2 and some of the use cases of EC2. And this use case we're going to talk about, or this architecture we're going to talk about, it notifies a group of users about a new letter. And the components or resources this architecture would need be first EC2 instance, then SNS, a simple notification service, and coupling EC2 and S3 service together. That's all it would require to get an architecture that notifies a group of users about a new newsletter. And now I think it would be a good time to talk about what EC2 is. AWS offers plenty of services offered under different domains like compute, storage, database, migration, network, management tools, media services, security, business productivity, application integration, machine learning, game development, and a lot more coming up, out of which EC2 falls under the compute capacity. So what is EC2? EC2 is a web service which aims to make life easier for developers for providing secure and resizable compute capacity in the cloud. With EC2, it is very easy to scale up or scale down our infrastructure based on the demand. And not only that, this EC2 service can be integrated well with almost all the services in Amazon. And out of all this, the best part could be we only pay for what we use. Alright, let's talk about this use case. A use case here is that a successful business owner has a bunch of users and a successful product that's running, and now he has developed a few more products that he thinks will be very successful, that he thinks his customers are going to like. Now how can he advertise his product to his new and prospective customers? Or the solution for this question can be addressed by AWS. In AWS, we can use services like Simple Notification Service, SNS, and EC2 for compute and S3 for storage. We can, in a way, integrate them all and achieve this business use case. And that sort of got this business owner very cheered up, and now he wants to use the service and he wants to get benefited from the service. He wants to advertise or he wants to notify his users every time the company creates a newsletter. Alright, so let's talk about what it would take to get this environment up and running, or what it would take to connect the environment and put the applications on top of it. Firstly, we would require an AWS account, and then for compute capacity, we would require an EC2 instance. And here's how we go about doing it. The first thing is to create an AMI, which is Amazon Mission Image. That's really the softwares and the application packages we would need to run our application. And the second is to choose the hardware. In here it's the instance type. Depending on the workload, we would be choosing the hardware, and depending on the intents of the workload, we will be choosing the size of the hardware. And finally, we would configure the instances. How many instances do I want? Which subnet do I want them in? And what's going to be the stop or terminate behavior of the instance, and do I want to update any patches when the instance starts running? All those pieces of information go in here when we configure the instance. And then the first three steps is really about the OS volume and the basic hardware. Now it's time to add additional storage to the EC2 instance. That would be step 4. Here we add additional storage to the EC2 instance. And then tags, we use tags, or we would configure tags to easily identify an EC2 instance at a later point. We give it some meaningful names so we can identify, like which team it belongs to, which billing department it belongs to, what's the purpose behind behind launching this instance, stuff like that. In an environment where we run 700 to 800 or even more instances, identifying an instance and trying to understand who owns the resource, for what purpose we created, it could be an full-time work. So tagging comes to our rescue at that time. After tagging, as step 6, we would configure the firewall, which is also called security group, for the EC2 instance. And this is where we would allow or deny connection from external world to this particular EC2 instance. Well, it works both ways, from outside and from inside out. This firewall blocks the connection based on port number and IP address. And finally, as step 7, we review all the configurations that you have done, and we make sure that the configurations is what we wanted, and finally click on submit. That's going to launch an EC2 instance. Alright, this was just an overview of how to create an EC2 instance. Now let's talk about each and every step in detail. So to begin with, let's talk about how to create an AMI. Well, the AMI is just a template that's used to create a new instance or a new computer or a new VM or a new machine based on the user requirement. The things that go into an AMI are the software, the operating system, the additional applications that get installed in it, stuff like that. The AMI will also contain software information, information about operating system, information about access permission, information about volumes. They all compact in the AMI. Again, the AMI is of two types. One is predefined AMIs, or called Amazon provided AMIs. The other one would be custom AMIs, the AMIs that we create. And if you're looking at a particular AMI that you don't want to create but still want to get it from Amazon, there is a place or a portal called AMI Marketplace. There we get like thousands of AMIs in there available for us to shop and use them on a pay-as-you-go business model, and use them as pay-as-you-go billing. So there you can search AMI that you're looking for. Most probably you'll be able to get it there. Now let's talk about choosing the instance type. The instance type is basically the hardware specification that's required for a machine that we're trying to build. And the instance types is categorized into 5 main families. They are, to begin with, it's compute optimized. Now compute optimized gives us lots of compute power or lots of processing power. So if my application is going to require a lot of processing power, I should be picking compute optimized instance. And the second one is memory optimized. Now this is very good for applications that require in-memory caching. There are some applications that performs well with cache or through cache, or the application would create a lot of data that it wants to keep in cache for rereading or for processing, for lengthy processing, stuff like that. For those type of application, this memory optimized instance that comes with in-memory cache is a very good use case. And the third one is the instance that comes with GPU, otherwise called GPU optimized. GPU stands for graphical process unit, and this is very good for application that deals with gaming. This is very good for application that's going to require large graphical requirements. And storage optimized is the fourth option. Just like the name says, this is a very good use case for storage servers. And the fifth family type is general purpose. Just like the name says, it's for general purpose. If you're not particular about the family, then you generally would end up picking the general purpose, because here the services are sort of equally balanced. You'll find a balance between the virtual CPU and the memory and the storage and the network performance. It's sort of balanced. All the components, all the features that needs to go in a computer are sort of balanced in general purpose. Now these instant types are fixed and they cannot be altered because it's hardware based. We buy hardware. We do not have much control on the hardware that's being used. Well, we have options, but we do not have control on the hardware. And these instant types are divided into 5 main families. They are compute optimized, memory optimized, GPU enabled, storage optimized, and general purpose. Then as third thing, we have to configure the instance. Now here is where I have a lot of options about purchasing. What type of purchasing do I want to do? Do I want to go for a spot instance? Do I want to go for a reserved instance? Do I want to go for an on-demand instance? These are different billing options available, and that's available under configure instance. Not only that, here's where I'm going to put the EC2 instance. Do I want an public IP address assigned to it? Do I want an IAM role attached to it? IAM role is authentication. Or what kind of authentication am I going to provide? And the shutdown behavior. The shutdown behaviors include, do I want to stop the instance when the user shuts down the machine from the desktop, or do I want to simply terminate the instance when the user shuts down the instance from the desktop? So those things go in here, just like the name says, configure instance. A lot of instance configuration options comes in here. That's the third step. And not only that, under the advanced details or advanced tab under configure instance, I can bootstrap the instance with some scripts. Now bootstrap is nothing but the scripts that you want to be run in the instance before it actually comes online. Let's say you're provisioning the instance for somebody else. Instead of you launching the instance and then logging in and running some commands and then handing it over to the other person, you can create bootstrap shell scripts and paste it in a console option available under configure instance, and Amazon is going to take those commands, run it on the instance before it hands over to the user that initially requested for that instance. Now it could be a different user or just you. It sort of automates software installation procedures in the instance that we will be launching. And not only that, there are multiple payment options available under configure instance. The user can pick an instance under normal price, and that instance would apply normal rates applied to it. And there are also options like reserved instance, where the user can pay for an instance upfront before a year or before months, for a span of year or a span of months, and that way they can pay less per hour for using that instance. Not only that, you can also go for spot instance, like bidding for those instances. Whoever bids more, they get the instance for that particular time. Well, these instances are a lot cheaper than on-demand instances. And through bidding and buying, you can keep the instance as long as your bid price doesn't exceed the price that Amazon is proposing. And as the fourth step, we will have to add storage to the instance that we are about to launch. And here we have a bunch of storage options. I can go for ephemeral storage, which is free, or I can go for an external elastic block storage, also called EBS, which is paid and it's a permanent storage, or else I can integrate my EC2 instance with S3 for its storage needs. And the best part about storage is free subscription users, they get to use 30 gigabit of SSD storage or magnetic storage for the whole year. In this page where we are ready to add storage, we will have to mention or provide the size in gigabit and the volume type. Is it going to be an provisioned volume? Is it going to be an general purpose volume? Is it going to be a magnetic volume? Stuff like that. They are volume types. And we also need to give inputs about where the disk will be mounted and whether this volume needs to be encrypted or not. So all these options or all these inputs are received from us under the adding storage section. And then the fifth option would be adding tags. Like we discussed some time back, tags are very helpful to identify a machine in an environment where we have 700 or 1000 VMs running. And security groups are the actual firewall that sits in front of EC2 instance, and it protects that EC2 instance from unintended inbound and outbound traffic. Now here is where I can fine tune the access to my EC2 instance based on port numbers and based on IP address from which it can be accessed. And finally, we get to review the whole changes or the whole configurations that we have made to find out whether they are intact with the requirement, and then click on submit. That's going to launch an EC2 instance. But hold on, we're not done yet. When we're about to launch, or before the Amazon console actually launches the EC2 instance, it's going to give us an option to create a key pair. Remember, I said it's key pair. Key pair is two things. One is public and private. The private key is downloaded by the user and is kept with the user, and the public key is used by Amazon to confirm the identity of the user. So just go ahead and download the private key and keep it for yourself. And this private key gets downloaded as an .pem file. It's a format of the file and it gets downloaded as .pem file. And our next step is to access the EC2 instance. And because the instance that we have launched in this example, let's assume it's a Linux instance, and that's going to require a tool called Putty to be able to access it. And this Putty tool is really needed when we are trying to access an Linux instance from Windows instance. Most of the time, Windows instance will have Putty installed in them, but in some rare cases, they do not come with Putty. In those cases, we can go ahead and download Putty and Putty Generator, and we can start using it to access the Linux instance. Now you might ask, well, I understand Putty, what's Putty Generator? Now the file that we have downloaded is in .pem format, but unfortunately Putty does not accept .pem format as input. It has to be converted into a different format called ppk. And Putty Gen is a tool that helps us to convert the .pem file into ppk file. So the quick way to do it is download Generator, open it up, click on conversion and insert the .pem key that we have downloaded and save the private key. And this, when we save the private key, it gets saved as a .ppk type private key. And when that's done, the next very step is to open Putty and try to log in. And the way to log in is to open Putty, put that IP address here, and then click on auth. This is where we would input the file that we have created. So click on auth and then click on browse and find the .ppk file that we have converted and stored, browse it and upload it, and then click on open. Now that's going to open up a login screen for us. And the AMIs comes with a default username. Depending on the AMI that we have picked, the username might differ. In our case, we have picked an AMI for which the username is ec2-user, and this is the default, by the way. Let's put the username ec2-user and hit enter, and that's going to open up the Linux instance using CLI. There are a few other things that we can do with the terminal that we'll explain it a little later. Alright, so we have successfully launched an EC2 instance, and give yourself a pat on your back. Launching an instance was just one part of the solution. So let's actually talk about how we can notify our customers. SNS, or Simple Notification Service, is a service or a product in Amazon that helps us to notify customers through email. So navigate to SNS in your account and create a topic. And we're going to use this topic for public notification. So let's make it public and then add subscribers to it. Now these subscribers are the people who you want to be notified about the newsletter. So we already have the email database in there. Add them to the subscribers list and then they will start getting new newsletters as and when we post them to the topic. And as next step, create a bucket in S3 where you can store content, and in that bucket create an event that triggers a notification to Simple Notification Service. So this is how it will be set up. A notification will be sent to our subscribers anytime we put something in our S3 bucket. So S3 bucket is going to create an event for the notification, and the notification is going to make sure that it's delivered to your end customer because they're already subscribed to the topic as subscribers. And finally, let's connect the S3 with EC2 so the bucket and the AWS instance are in sync. So we put some content in the S3 bucket, our email system notifies our customers, and the customers can go online to a website that's hosted in EC2, and because S3 and EC2 are in sync, the items that we put in S3 will also show up in EC2. See how this is all connected and it's working together. And once this is all connected, our subscribers will regularly be informed anytime we put new content in the S3 bucket, and the same content will be made available in EC2 instance through the website. So what did we learn? We learned about how EC2 can replace the hardware system for computing, and we can go virtual where we don't have to manage anything, and also the environment is scalable in a couple of button clicks, and it also provides pay as we go type of subscription. And not only that, we have full control of the environment and it's highly secure at the same time. And then we learned about what EC2 is, what EC2 can do, and how well it integrates with other services in Amazon. We also looked at in detail about how to provision an EC2 instance, a step-by-step approach. And finally, we talked about a use case. Where a business owner wants to notify his users about the new product that he is developing, and anytime that's available, he wanted an email to go out to the customer notifying about the new product, and the customers can come online and check it on the EC2 instance that he was running. Alright, I believe that was a good amount of explanation about what EC2 is and how it gets connected, how to provision, and how to go about building an architecture like we saw. Hi there, welcome to this new video series called S3 Tutorial. I'm Samuel, and Cloud Architect and Evangelist working for Simplilearn. And I'm going to be touring you with different S3 features and technical details in this section. So what are we going to learn? We're going to learn about what is cloud storage in general, and then the types of storage available in general in the cloud, and how things were before anybody adopted using S3. That's something we're going to learn. And then we're going to immediately dive into what is S3, and then the benefits of using S3 over other storage. And then we're going to do a couple of labs or console walkthroughs about what is object and how to add an object, what is bucket, how to create a bucket, stuff like that. And then we're going to talk about how Amazon S3 generally works. Now, it comes with a lot of features, it comes with a lot of promise. How does this all work? How does Amazon able to keep up with the promise? We're going to talk about that. And then we will talk about some features, add-on features that comes along with Amazon S3. So what is cloud storage in general? Cloud storage is a service that provides web services where we can store our data. And not only that, the data can be easily accessed and the data can be easily backed up, everything over the internet. In short, if you could store your data, if you could access the data, if you could back up your data, everything you do through the internet, then that's a good definition for cloud storage. And additional definitions are, in cloud storage we only pay for what we use. No commitment, no pre-provisioning, is pay as you go type subscription. And the best part is we pay on a monthly basis. We don't rent a hardware for the year, or we don't give commitment for the whole year. It's pay as you go and pay on a monthly basis. And these cloud storages are very reliable, meaning once you put the data in it, it's never going to get lost. And these cloud storages are scalable. Assuming I have a requirement to store 100 times of what my actual data size is, and I want it now, it's available in the cloud. And these storages are secure as well, because we're talking about data virginity. They need to be secure, and Amazon provides tools and technologies through which we can secure our data, and these are generally not found in the on-premises storage system. So let's talk about the different types of storage in general. So S3 is cloud storage in AWS, and then we have Elastic Block Store. Now, Elastic Block Store is actually the SSD hard drives that gets attached to our EC2 instance. It's like the C drive, it's like the D drive, it's like the E drive that gets attached to our instances. Now, EFS is Elastic File System. The underlying technology is kind of the same, but it differs from EBS in a way that EBS can be accessed only by the system that's attached to it, meaning the E volumes and the D volumes we spoke about. They can be accessed only if there is an instance connected to it. But these EFS are actually shared file systems, Elastic File System. Alright, they are shared systems. They can be accessed by multiple systems. They can be accessed from inside the Amazon environment. It can be accessed from on-premises equipment as well. Glacier is actually the archiving solution in the cloud. If you want to dump a data and try to keep them in the low cost as possible, then Glacier is the product we should be using. And then we have Storage Gateway. If I want to safely move my data from my local environment to the cloud environment, and also want to keep a copy of the data locally, so users locally can access them, and cloud users or internet users can access the data from the cloud. If that's your requirement, then Storage Gateway is the one we would be choosing. And then we have Snowball. Snowball is really an data import and export onboard system, but it is actually an hardware that gets shipped to our premises where we can copy a data into it and then ship it back to Amazon, and Amazon would copy the data into whatever destination we give them in our account. And if the data is really huge, then I can call for a snowmobile, which is actually a data center on a truck, where Amazon would send me a truck loaded with a data center, as you see, that has compute capacity, lots and lots of storage capacity, and electricity, AC, and a lot more. So they get come parked near our data center, and cables run into our data center. We can copy data into it, send it back to Amazon, and they would copy it to our account in whatever storage that we advise them. So if the data is really huge, then I would be calling snowmobile. Snowmobile is not available in all the regions. All right, let's take this example, how things were before S3 was introduced. Two professionals are having a conversation, and one of them is finding it very difficult to sort of manage all the data in the organization. Well, if the data is small, it can be easily managed, but as company grow, and we are living in an era where data is everything. We want data to back up every idea. We want data to back up every proof of concept that we provide. So data is everything. So this era, it's all about collecting data, analyzing them, and saving, not losing logs, saving them, analyzing, stuff like that. So coming back to our discussion, here one person finds it very difficult to store and manage all the data that they have. So some of the data that this person is having problem storing is data that application use to running, and then data that get sent to the customers, and data that the websites require, the data that are because of the email backups, and a lot more other storages that an enterprise can have. And this person is having problem backing up all those data. And even if we think of increasing the local storage capacity, that's going to cost a fortune. And few things that make it sometimes impossible to increase the storage capacity in-house is we will have to go and pay heavy to buy hardware and software to run these storages, and we need to hire a team of experts for maintaining them, the hardware and the software. And anytime if there is a dynamic increase in the storage capacity, the on-premises or in-house hardwares won't be able to scale. And data security is very costly when it comes to building our own storage environment in-house and adding data security on top of it. So the other guy in the conversation was sort of quietly listening everything the manager was saying, and then he slowly introduced him to S3, because he knew that all the problem that this manager was worried about can be solved to S3. In other words, all the scalability, all the data security, all the not being able to provision hardware and software components are all available with S3. So that actually brings us to the discussion about what S3 is. S3 is simple storage service. It actually provides an object storage service. Let me talk to you about object and block storage. Object storage is where you can store things into drive. All right, you can't install anything in it, and this object storage can be accessed directly from the internet, whereas block storage is something that needs to be attached to an instance, and we can't directly access it, but we can install software in it. So that's a high level difference between object storage and block storage. And S3 is an object storage. What does that mean? We can store data from the internet, we can retrieve from the internet, but we can't install anything in S3. All right, so S3 is an object-based storage, and it's really built for storing and recovering or retrieving any amount of data or information from anywhere in the internet. Few other things you need to know about S3 is that this S3 is accessible through the web interface. The storage, one type of accessing or one way of accessing S3 is by dragging, dropping content into it, and another way of retrieving data from S3 is go to a browser, click on download. That's going to let you download any content, and the data can be 5 terabytes in size. Now we're talking about one file. You can have hundreds or thousands of files like that. One file can be as big as 5 terabytes in size. And S3 is basically designed for developers where they can push logs into S3 or retrieve logs anytime they want instead of storing locally in the server. They can use S3 as code repositories, where they can save the code and have the applications read the code from there, and a lot more. If they want to safely share the code with another person with a lot of encryption and security added on top of it, that's possible as well. So there are a few things about S3, and on top of all this, S3 provides 11.9 durability and 4.9 availability, meaning durability is if I store the data, will it get lost? Amazon is like, no, it's not going to get lost. You're going to have the data because we provide 11.9 durability for the data. And availability is if you want the data now, will you be able to show it? Amazon is like, yes, we will be able to show it. We have 99.99% availability, and when you request the data, we will be able to show the data to you. Alright, so let's talk about the benefits of S3. S3 is durable. As we saw, it provides 11.9 durability. S3 is low cost. Out of all the storage options in Amazon, S3 is the cheapest, and S3 is very scalable. Like we were saying, there's no required to pre-provision a storage capacity. If you need more, go ahead and use more. If you need even more, go ahead and use even more. And once you're done, some data needs to be removed, just remove the data. So that particular month you would be paying less. So it's very scalable in nature, and it's very available as well. S3 isn't regional service. It's not based on one availability zone. So one availability zone going down within Amazon, the whole availability going down, it's not going to affect your ability to access S3 storage. And S3 is secure. A lot of security features like bucket policy, a lot of security features like encryption, and then MFA authentication are possible with S3 that actually adds a very good security layer on top of the data that we have stored in S3. And not only that, this S3 is very flexible in terms of cost, flexible in terms of where I want to store the data. In terms of cost, there are a lot of pricing tiers within S3. S3 itself is a cheap service. Now within that, we have a lot of pricing tiers depending on the durability. So I can always choose to put data on a different storage tier or storage option in S3. We're going to talk about it as you stick along. And in terms of flexibility in region, I can always choose any of the region available in the console or in the S3 console to put my data to. There is no restrictions on where I can or cannot put the data in the cloud, as long as there are regions available for me to move the data to. And data transferring with S3 is very simple. All I have to do is browse to the bucket, upload the data, and the data gets uploaded. And we can also upload data using CLI. Commands are very similar to Linux. Commands are very similar to what we would use in the run command prompt in Windows and what we would use in the run command prompt in the PowerShell. All right, let's talk about a basic building block of S3, which is bucket and objects. Now what's a bucket? What's an object? Object is the actual data, and bucket is the folder where the objects get stored. Let me give you a new definition for object. So object is the actual data plus some information that reference the data, like is it an JPEG file, the name of the file, and at what time it was added to. So they're called metadata. Alright, so object is actually data plus metadata, and bucket is actually a container that receives the data and safely stores in it. And when we add a data in a bucket, Amazon S3 creates an unique version ID and allocates it to the object so we can easily identify it at a later point. Let me show you a quick lab on S3. Alright, I'm in the S3 console. If you're wondering how I reached here, go to Services, under Storage, and S3 is right here. And let's create a bucket called Simply Learn. Now the bucket names will have to be unique. So I really doubt if simply learn will be available. Let's check it anyway. All right, it doesn't seem to be available. So let me pick another name, or let's call it simply learn.samuel.com, and I'm going to put this in Mumbai, or I can choose Oregon. Let me choose Oregon. Yes, let me choose Oregon. And let me create a bucket. Sure enough, a bucket got created. Let me upload an object into the bucket. And you know, these objects can be as big as 5 terabytes. We talked about it, right? All right, let me upload an object. All right, so that's my object. So you get the relation, right? Here's my bucket. All right, here's my bucket, and within that is my object. Now, object is the actual file plus what type of file it is, and then the size of the file, the date in which it got added, and the storage class it is in at the moment. So if I have to access it, I can simply access it through the internet. So let's talk about how does this S3 bucket work anyway. Alright, so how does it work? A user creates a bucket. They will specify the region in which the bucket should be deployed. We had an option. We could have chosen to deploy in all the regions. Amazon provides S3 service, you know, be it North Virginia, be it Mumbai, be it Tokyo, be it Sydney, be it Oregon. And we chose Oregon to be the destination region where we want to create a bucket and save our data there. And when we upload data into the bucket, we can specify 3 types of storage classes. In our case, we picked the default, which was S3 standard. As we saw on the object data, it was on S3 standard. So that's the basic thing. Later, once the object gets added, we can always add bucket policies. You know, policies define who access it and who should not access it. What can they access? Are we going to allow users only to read or to write as well? Stuff like that. So that's bucket policy. We're defining the life cycle or the lifespan of the data in the S3 bucket. Now, over the time, do you want the data to automatically move to a different storage tier? And at any point, do you want to sort of expire the data, you know, get the data flushed out of your account automatically? You know, those things can be configured in lifecycle policies. And version control is creating multiple versions. If you're going to use S3 for a code repository, creating multiple versions. Let's say if you want to roll back to whatever you had before a month, how are we going to do it if you kept updating the file and never took a version of it? So version control helps us to keep different versions, and it helps us to roll back to the older version anytime there is a need. So let's talk about the different storage classes in S3. The different storage classes in S3 begins with S3 standard. Now this is the default, and it's very suitable for use cases where you need less or low latency. For example, if you want to access the data of a student's attendance, you would retrieve them very quickly as much as possible. So that's a good use case to store data in S3. Let's understand the different storage classes in Amazon S3. Now let's take a school, for example, and the different data present in a school, and the features of those data, the validity of the data. All right, so let's take this example, and there are different storage options in S3. Let's take S3 standard for example, and what would be the actual candidate data that can be stored in S3 standard. Let's talk about that. So S3 standard in general is suitable for use cases where the latency should be very low, and in here the good example or the good candidate file that can be stored in S3 is data that needs to be frequently accessed and that needs to be retrieved quickly. Something like students' attendance report or students' attendance sheet, which we access daily, and then it needs to be retrieved immediately as and when we need it. The other type of storage tier in S3 is infrequent access or infrequent data access. Just like the name says, the use case for that is less frequently accessed data. I mean, the candidate data that should go in infrequent access data is a student's academic record, which we don't need to access on a daily basis. But if there is a requirement, we might want to go and look at it, and that's going to be quick. So it's not a data that we would access on a daily basis, but it's a data that needs to show up on your screen real quick. And the third option is Amazon Glacier. Now, Glacier is really an archival solution in the cloud. So for archives, high performance is not a requirement. So let's talk about some candidate data that can go into archives. Something like students' admission fee, and it's not critical also. Now, anytime if you want to look at the data, you can always wait to retrieve the data. So in other words, put it in the archive, and retrieving from the archival takes time. So students' old record are a good candidate to be put in the archives. The other options are one zone IA storage class, where the data is infrequently accessed and the data is stored in a single availability zone. For example, by default, Amazon stores data in multiple availability zones, and there is a charge for that. Now, it's not an option, but the charge includes storing data in multiple availability zones. But if your data requirement is you want to keep the charges low even further, you can choose a one zone IA storage class where it stores data in one availability zone. And the candidate data that can go in one zone infrequent access is student's report card. And the other option with Amazon S3 is standard reduced redundancy storage. It is suitable for cases where the data is not critical and the data can be reproduced quickly. For example, take a copy of the library book, take a copy of the PDF library book, for example. Now, we would have a source PDF and we would make copies of it, and then we make it available for the readers to read. The other option in S3 is reduced redundancy storage. Here the use case is data that's not critical and data can be reproduced quickly. For example, books in the library are not that critical and we always have a copy of the book. We're talking about PDF. So if the customer facing or the student facing book gets deleted, I can always copy the same PDF, put it in the destination folder and make it available for the users to read. That would be a very good use case for reduced redundancy storage. All right, let's summarize everything that we learned about different storage options in S3. So S3 standard, it's for frequently accessed data. It's the default storage. If you don't mention anything, the data gets stored in S3 standard. It can be used for cloud applications, content distribution, gaming applications, big data analytic, dynamic websites. They are a very good use case for S3 standard frequently accessed data. The other one, on the contrary, is S3 standard infrequently accessed data. Just like the name says, the use case is this is good for data that will be less frequently accessed, and then the use case are it's good for backups, it's good for disaster recovery, and it's good for lifelong storage of data. Glacier, on the other hand, is very suitable for archiving data which is infrequently accessed, and the vault lock feature is the security feature of the Glacier that also provides a long-term data storage in the cloud. This is the lowest storage tier within S3. The other options are one zone infrequent access storage class. Just like the name says, it's infrequently accessed and it is stored in just one availability zone. And use cases are any data that doesn't require any high level of security can be stored here in one zone. The fifth storage tier is reduced redundancy storage. This is good for data that's frequently accessed. It's good for data that is non-critical and that can be reproduced if it gets lost. And reduced redundancy storage, or RRS, is an highly available solution designed for sharing or storing data that can be reproduced quickly. All right, let's compare and contrast a couple of other features that are available in S3. For example, durability, availability, SSL support, first byte latency, and lifecycle management. So in standard, the durability is 11.9 durability. It's the same for standard IA, one zone IA, Glacier, except for reduced redundancy, the durability is 11.9. And availability of all the storage classes is all the same, except for one zone IA, where the availability zone is 99.5%. All of these products support SSL connection, and the first byte latency of these products are, most of them provide access with millisecond latency, except for Glacier. It provides a retrieval time of couple of minutes to a maximum of hours, and all of them can be used for a lifecycle management, moving data from one storage tier to another storage tier. That's possible with all of these storage options. Alright, now that we've understood the different types of storage options available in S3, let's talk about some of the features that are available in S3. Lifecycle management. Now, lifecycle management is a service that helps us to define a set of rules that can be applied to an object or to the bucket itself. Lifecycle is actually moving the data from one storage tier to another storage tier and finally expiring it and completing the life cycle of the object. With lifecycle management, we can manage and store our objects in a very cost-effective way. It has two features basically: transition actions and expiration actions. Let's talk about transition actions. With transition action, we can choose to move the objects or move the data from one storage class to another storage class. With lifecycle management, we can configure S3 to move our data from one storage class to another storage class at a defined time interval or at a defined schedule. Let's talk about transition actions in more detail. Let's say we have our data in S3 at the moment and we haven't used the data for quite some time, and that's how it's going to be for the rest of the time. So that data is a very good candidate to move to the infrequent access, because S3 standard is a bit costlier and S3 infrequent access is a bit cheaper than S3 standard. So the kind of usage sort of fits very well for moving that data into infrequent access. So using lifecycle transition or lifecycle management, I can move the data to S3 infrequent access after 30 days. And let's say that the data stayed in infrequent access for 30 more days, and then now I realize that nobody is looking into the data. So I can find an appropriate storage tier for that particular data again, and I can move it to that particular storage tier, which is Glacier. So in this case, after 30 days or in a total of 60 days from the time the data got created, the data can be moved to Glacier. And what does this really help us with? The lifecycle management helps us to automatically migrate our data from one storage cost to another storage cost, and by that it really helps us to save the storage cost. Lifecycle management can also help us with object expiration, meaning deleting the object or flushing it out after a certain amount of time. Let's say that our compliance requirement requires that we keep the data for 7 years, and we have like thousands and thousands of data like that. It would be humanly impossible to check all those or keep track of all the dates and when they need to be deleted, stuff like that. But with lifecycle management, it is very much possible. I can simply create a data and set up lifecycle management for the data to expire after 7 years, and exactly after 7 years the data is going to expire, meaning it's going to be deleted automatically from the account. Alright, let me show you a lab on lifecycle management and let me explain to you how it's actually done. So I'm into the bucket that we have created, and here's our data into the bucket. Assume we have thousands and thousands of data in the bucket, and that requires to be put in a different storage tier over time, and that requires to be expired after 7 years, let's say. So the way I would create a lifecycle management is go to management from inside the bucket and click on lifecycle, and then add a lifecycle rule. just give it a name like expire. So all the objects that's present in this bucket, meaning the current version of it, set a transition for it. So the transition is, at the moment they are in S3. So here I would like to put them in infrequent access after 30 days. And then after it's been in infrequent access for 30 days, I would like to move it to Glacier. All right, plus 30 days. So how do you read it? So for the first 30 days, it's going to be in Glacier. So how do we actually read it? So after I put the data in S3, the data is going to get moved to standard IA, and then it's going to stay in standard IA, and after 60 days from the data creation, it's going to get moved to Glacier. So on the 31st day, it's going to move to standard IA. On the 61st day, it's going to move to Glacier. Let's say if I want to sort of delete the data, if I want the data to get deleted automatically after 7 years, being in a Glacier, how do I go about doing it? Let me open up a quick calculator. 365 into 7, that's 2,555 days. Right after that, the data is going to get deleted. Pretty much I have created a life cycle. So on the 31st day, it's going to get moved to infrequent access, and on the 61st day, Glacier, and after 7 years is over, any data that I put in the bucket, it's going to get deleted. All right, let's talk about bucket policies. Bucket policies are some permission files that we can attach to a bucket that allows or denies access to the bucket based on what's mentioned in the policy. So bucket policy is really an IAM policy where you can allow and deny permission to an S3 resource. With bucket policy, we can also define security rules that apply to more than one file in a bucket. Now, in this case, we can create an user, or let's say there's already a user called simply learn, or we can allow or deny that user connection to the S3 bucket or connecting to the S3 bucket using bucket policy. And bucket policies are written in JSON script. And let's see how that's done. All right, there are tools available for us to help us create bucket policies. What you're looking at is a tool available online that helps us to create a bucket policy. So let's use this tool to create a bucket policy. I'm going to create a deny statement. I'm going to deny all actions to the S3 bucket. And what is the ARN to which we want to attach? The ARN of the resource is actually the name of the bucket, but it really expects us to give that key in a different format. So the ARN is available right here, copy bucket ARN. So this is actually going to deny everybody. Now we wanted to deny a user, just one user. Now look at that. Now we have a policy that has been created that's denying access to the bucket, and it's denying a user called simply learn. Pretty much done. So I can use the policy and go over to bucket policies. So once I save it, only the user called simply learn won't have access to the bucket, and the rest of them will have access to it. So once I save it, it gets added, and only the user simply learn will not have access to the bucket because we're denying them purposefully. The other features of S3 include data protection. We can protect our data in S3 with now one of which is bucket policy. I can also use encryptions to protect my data. I can also use IAM policy to protect my data. So Amazon S3 provides a durable storage. Not only that, it also gives us a protected and scalable infrastructure needed for any of our object storage requirements. So here the data is protected by two means. One is data encryption and the other one is data versioning. Data encryption is encrypting the data so others won't get access, or even if they get access to the file, they won't be able to access the data without the encryption key. And versioning is making multiple copies of the data. So let's talk about them in detail. What's data encryption? Now, data encryption refers to protecting the data while it is being transmitted and protecting the data while it is at rest. Now, data encryption can happen in two ways. One is client encryption, encryption at rest, and server-side encryption, encryption that's in motion. Client-side encryption refers to when client sends the data, they encrypt the data and send it across to Amazon. And server-side encryption is when the data is being transferred, they get encrypted and stay encrypted throughout the transfer. Versioning is another security feature. It helps us so our unintentional edits are not actually corrupting the data. For example, let's say you edited the data and now you realize that the data is incorrect and you want to roll back. Now, how do you roll back? Without versioning, it's not possible. In other words, only with versioning, it's possible. So versioning, it can be utilized to preserve, recovery, and restore any early versions of every object that we stored in our Amazon S3 bucket. Unintentional erases or overwrites of the object can be easily regained if we have versioning enabled. And it's possible only if we have one file with the same key name, and anytime we update the file, it keeps the file name but creates a different version ID. Take this bucket and data for example. Photo.pmg is a file that was initially stored. It attached a version ID to it, and then we edited it. Let's say we added some watermark, we added some graphic to it, and that's now the new version of it. When we store it with the same file name. It accepts the same file name but creates a new version ID and attaches it. Anytime we want to roll back, we can always go to the console, look at the old versions, pick the version ID, and roll back to the old version ID. Alright, let's take this example. Now, I'm in a bucket that we've been using for a while, and let me upload an object. Now, before we actually upload an object, this bucket needs to be versioning enabled. So let me version enable this bucket. From this point onwards, this bucket is going to accept versioning. So let me upload an object, photo.jpg. Let me upload it. All right, it successfully got uploaded. Good enough. It's uploaded. Now, let me upload another object with the same file name. Now look at that. It was uploaded at 7:35 a.m. Let me upload another object with the same file name that I have it stored right here. That got uploaded but with the same name. Alright, so that's the other photo. Now what if I want to switch back? The way I would switch back is simply switch back to the older version. Look at that. This is the latest version and this is the old version that I have. I can simply switch back to the old version that was created at such and such time, and I can open it. That's going to open the old file. So in short, it creates different version of the data that I create as long as it's with the same name, and at any point I can go and roll back to the original data. This is a very good use case if you want to use S3 for storing our codes. Let's talk about other feature like cross-region replication. Now, cross-region replication is a very cool feature if you want to automatically keep a copy of the data in a totally different region for data durability, for any additional data durability, or if you want to serve data to your customers who live in another country or who are accessing your data from another country. If you want to serve the data with low latency, cross-region replication is a very cool feature that you can use and get benefited from. And let's see how that's done. So before we actually do a lab on cross-region replication, let's put together a proper definition for it. Cross-region replication is a feature that provides automatic copying of every object uploaded to our bucket or your bucket, source bucket, and it automatically copies the data to the destination bucket, which is in a different AWS region. As you see here in the picture, I put data only in region 1. It's going to copy the data to region 2. And for us to use cross-region replication, versioning must be turned on. So it creates versions and copies the versions as well. If tomorrow the original region goes down, let's say the other region will be active and it has the complete data that was present in the original region. Or at any point, if we want to simply cut the region replication and use the other bucket as a standalone bucket, it can be used as well, because it already has all the data that was present in the master or all the data that was present in the original replication bucket. Let's see how that's done. So there are two things needed. One is versioning and another one is role. When we transfer data from one bucket to another bucket, we need proper permissions to do so, and these roles, they give us proper permissions to transfer data from one bucket to another bucket. Let's see how that's done. Right, so here's my bucket, a bucket in US Oregon. Let's create another bucket in Mumbai. Call it .mumbai.com and put it in Mumbai, or create that bucket in Mumbai. There you go. We have one in Oregon, we have one in Mumbai. We're planning to replicate or create replication between these two, right? Create replication between these two buckets. So go to the first bucket, go to management and start a replication. Add a rule. So all content in this bucket is going to get replicated. This is my source bucket. It's quite simple. Select the destination bucket. Now my destination bucket is going to be simply learn.samuel.mumbai.com. Alright, it says, well, you have versioning enabled in your source bucket, but not on your destination bucket. Do you want to enable it now? Without which we won't be able to proceed further. So let's go ahead and enable versioning through the console. That shows up. And then, like I said, it's going to require permission to put data onto the other bucket. Now I can create different roles. These are different roles that are used for different other services. I can also choose to create a role that specifically gives permission only to move the data from one bucket to another bucket. Pretty much it's done. So if I go over to my source bucket and if I add some data to it, let's say index.html, assuming I'm adding some files to it, in theory they should move to the other region automatically. There you go. I'm in the Mumbai region and the datas, they got moved to the other region automatically. Let's talk about the other feature called transfer acceleration. Now it's a very handy and a helpful tool or a service to use if we are transferring data which is very long distance from us, meaning from the client to the S3 bucket. Let's say from my local machine, which is in India, if I transfer the data over to Oregon, let's say, it's a long distance. If it is going to go through the internet, it's going to go through high latency connections, and my transfer might get delayed. If it is an 1 gigabit file, it's okay. But if we're talking about anything that's 5 terabyte size, if you're talking about anything that's a 5 terabyte in size, then it's not going to be a pleasant experience. So in those cases, I can use transfer accelerator which in a secure way, but in a fast way or a fastest way, transfers my data from the laptop or from client to the S3 bucket. And it makes use of a service called CloudFront to transfer or to enable the data acceleration. So the way it would do it is, instead of copying the data directly to the location, instead of copying the data directly to the destination bucket, it copies the data locally into a CloudFront location, which is available very local to whatever place we are in, and from there it copies the data directly to an S3 bucket, not going through the internet. It helps eliminate a lot of latency that could get added when transferring the data. So let's see how that's done. Right here, I'm in the S3 bucket, and under properties I can find transfer accelerator, and if I enable transfer accelerator, so I'm in another bucket. Let me go to properties and let me go to transfer accelerator and enable transfer accelerator. So now if I put data into this bucket, they're going to get copied to the local CloudFront location, and from there they're going to get copied to the S3 bucket from the CloudFront. Now if I need to compare how the speed is going to be compared to directly putting the data to the internet and using CloudFront, there is a tool available that actually runs for a while and then comes with a report that tells me how much will be the improved speed if I use transfer accelerator, and it shows for all the regions available in Amazon. So from the source to the destination, if you want to put what's the normal and what's the accelerated speed when you transfer the data, those results we will get in the screen. So at the moment this tool is going through its testing, like uploading some file through the internet and uploading some file using CloudFront, and it has come up with the calculation that if I'm uploading file to San Francisco compared to uploading through the internet and through CloudFront, it's 13 times faster. So similar way, it's going to calculate for all the regions available and it's going to give me a result. All right, let's summarize. What did we learn? We started a learning with the types of storages available in the cloud, like S3, EFS, EBS, Glacier, Storage Gateway, Snowball, and 2 types of snowballs available. And then we gradually started to discuss about what is S3 and then the benefits of S3, the durability, the cost, the scalability, the availability, the security, and the flexibility, and the different simple ways of data transfer that S3 offers. And then we did a couple of labs about creating a bucket, creating cross-region replication, creating a bucket policy, things like that. And then we discussed a lot of features that S3 provides, like restricting access, versioning, things like that. And then we discussed a few features of S3, like versioning, creating a bucket policy. How do I secure data in S3? I believe you really enjoyed this session. We will meet again in another similar session like this. Thank you. Bye for now.
So that's all for today's lecture. We already are we are done with AWS, the storage and other details like features provided by AWS, the history of AWS and all. Also some light is been given or thrown on S3 and the features. So we will stop over here. The remaining details we will see in the next lecture. Okay, thank you for now. You can put your attendance in the chat and leave the session. Thank you. Akanksha Kshirsagar, put your attendance and leave. Renuka Kadam.